Get your hoodies, get your noise cancelling headphones, some water, because we are going to create ZK apps, which is a privacy preserving application using ZK proofs on the Mina blockchain. You can start by looking at the Hello World tutorial on the Mina developer docs. I will also release a tutorial as well that will have the steps for this video. I'm going to assume that you have Node installed. If not, the tutorial has a few steps. The first thing you need to do is install the ZK app CLI on your terminal. To access your terminal, you go into Launchbar, you click Terminal. I'm assuming you're using a Mac, but find the equivalent command for Windows. So once you do this step, npm install, and then you just want to confirm that the installation was successful by typing ZK version. Beautiful. So now we can create a new project. The command for creating a project is called ZK project. Then you name it. I'm going to call it my ZK app. You can name it anything. A ZK app is made up of a smart contract and a UI. In this case, the UI will be the terminal for now, just to make it as simple as possible. So click None. It'll set up the project. It's installing some files. Okay, awesome. Now I'm going to change the directory in my terminal to the direction of the app. So I just type cd, which stands for change directory, my ZK app. So you can see the files that are in there. Now I want to open this in a code editor. I'm going to use Visual Studio Code and I'm going to open the folder. All right, awesome. So if we just explore it a bit, if you go into source, that's normally where the code exists. So they already have some files that have been added. For example, add, test, add.ts, index, interact. Okay, so for us, we are not going to use this code. So I am just going to remove everything inside here because we're going to create our code from scratch. So I'm just going to remove this. I'll keep the imports for now because I may need them. And I'm going to call this age verifier. Okay, so the reason why the test file is erroring because it's expecting a smart contract called add, but that doesn't exist yet. So I am just going to continue with this for now because we will not be compiling anytime soon. So this is where we will set up the smart contract that will be deployed on the blockchain if we deploy it. We're going to write a ZK app, and the aim of the ZK app is to only allow persons who are at a valid age to edit the age limit. The person who is using a smart contract has to be at the age limit or above. And if they are, then they are able to edit what the age limit is. Kind of controversial, but let's see how this app goes. First thing we need to do is actually think about what is the age limit that we're going to use. The age limit will be a state in the contract, and on Mina blockchain, you can actually have up to 8 state variables. And in order to write a state, you can see here in the developer docs, they say that it has an on-chain state named num. So we're going to follow this exact we're going to follow the syntax for creating our state. So in our case, we're going to use the decorator state. It's going to be a type field, which is the most basic field type on snarky.js, which is the library that we're using to be able to write this code in Typescript. And we're going to call the state age limit, and it's equal to state of type field. All right, awesome. So next we're going to have a function, and this function is what is basically creating our ZK proof. In this function, we'll have the constraint that says whether or not the person is of age and if they can change the age limit. So we're going to use the method decorator, and we're going to say verify age, and the input is going to be user age. We can name it anything. It's going to be our type field. And age limit update, since they can update the age limit. There's also going to be a type field, close brackets. So the first thing we're going to do is get the age limit from this smart contract. Now, what is the age limit in this smart contract? I'm not too sure yet, but let's just get it. So to get the age limit, we're going to use a simple getter. So we're going to say constant current age limit equals this dot age limit dot get, not length. Okay. Okay, so that gives us the age limit. No, it doesn't exist on type. Let's see. Oh, we have to put these 2 brackets here. All right, so dot get. Oh, so I had an error, by the way. I need to put these 2 brackets here. All right, awesome. And now that we have the current age limit, there's one thing to know about Mina protocol, and that is when you are running the smart contract code, the smart contract is actually executed offline. So we have to just make sure that the smart contract that we're executing offline has the correct state, and it would be the state that's stored on chain. So the way that we'll do that is that we will get the one that's on chain by using the getter, and then we're going to say dot assign equals the current age limit on chain. Awesome. Now the next step, which is probably the most interesting part, where you define your logic as a programmer as to what satisfy the ZK proof before we allow them to do any updates to the smart contract. So the criteria to satisfy this ZK proof right now is to check to see whether the age that the person has sent is the age limit that we have for the smart contract. So then we're going to say user age dot assert equals the one that we got, current age limit. Awesome. Before we continue, I'm just going to show you a way to simplify your code a little bit more. So you see how we're saying get and then assert equals. There's actually another method, or probably a new method, where you can do get and assert equals in one line. So you don't have to do this here. So now we know that the state variable that we received from the blockchain is currently the one that we're using in the smart contract execution. Once this line is satisfied, then we can allow the user to update the age limit. We will then use a set method to do this. So this dot age limit dot set age limit update. Bada bing, bada boom. So the most important line here for defining your constraint for a ZK proof is actually this line here that says assert equals. There are many different types of assertions. We can even add some more logic that says only if the age limit is greater than or equal to 18, then they are able to also update the age limit. So let's say the person is 18, they satisfy the first criteria because we're assuming the age limit is 18. And then we're saying, if you would like to update the smart contract age limit, it needs to be greater than 18. Don't say a 12-year-old can now use the application. That is not okay. These are the two criteria we've set for determining whether or not this is a valid. There's one thing missing right now, and we need to actually set what this age limit is. And there is an initializer method called init that you can write. And in the initializer method, you can say what the age limit is. So using the same set method, you can say this.ageLimit.set, and then you can write 18. So now we've set that, and this method will only be run once when the smart contract is deployed. So now that we have this, how about we change the name of the smart contract actually to age verifier, update imports for age verifier, yes. And how about we go here and we change wherever we see add to the name of the smart contract, which is called age verifier as well. And wherever we see add, we also change it. And then here, age verifier. All right, so we don't have this method called update anymore. What do I need to do next? So let's just see what this code does. So this code was included when we did the ZK project command. And it essentially is a test. This is not the way that you'd normally send transactions to a smart contract, but I think this is a good way for you to test to see if your code is working. It's basically creating the steps required for a local Mina blockchain. So this means it is not on the actual testnet, it's just locally on your computer. Let's walk through the test code. So on this line here is setting a variable proofs enable as false. And basically, if proofs enable is set to true, then it will actually compile the code. In this test run, we don't need to compile it. Because we're testing this locally, there's no need to actually compile the code. When you compile the code, that's when you create the proofs required for running the methods and the verification key, which is required to deploy your ZK app. So before each method, we will create a Mina blockchain and set an active instance as local. And then we will create two accounts. One is used for simply deploying the smart contract. Another one is used for interacting with the smart contract. So here you see we have the deployer account. It's being funded so that it can pay gas fees, and then it is going to do ZK app deploy. So according to the documentation, what this line does is that it goes through your transactions and looks for anything that's happening and making sure the transaction is valid, such as account updates. The transaction may not only be responsible for validating a proof, such as a ZK proof that you create, but they also need to validate other things within the transaction, such as, does this person have enough funds in their account to be able to deploy this transaction, for example? I think Mina uses cryptographic proofs to validate everything about the transaction. So I think that's quite interesting. So at this step here, the transaction is signed by the private key of the deployer account, and then we're sending the transaction to our local instantiation of the blockchain just within the code. So the first step here is we're going to generate and deploy the add smart contract. So in our case, it's the age verifier smart contract. And instead of getting num, we're getting age limit, which is our state variable. And we're just expecting it to be equal to 18 because that was what we set it as. And that's the first method. The second one is correctly updates the state. So we need to update the state, which is the age limit, to something that makes sense. So let's just change the name here, age verifier smart contract. And instead of calling update, we're going to call verify age. And we're going to pass two fields. We're going to pass the age of, let's say, 20. And that person is going to update it to 21 as the age limit. And then we just want to verify that it has been updated. So we have to get the age limit here. And then we're going to make sure that the updated number is now 21 because that's what we said the age limit would be. So now to run this test, we will need to go here and then we can say npm run test. Is it called add.test? I need to rename this the age verifier.test. So let's rename this to age verifier.test. One failed. Oh shoot, I have an error in my smart contract, guys. The error is that I need to set this to be greater than or equal to the age limit. Thank you. So let's try that again. All right, cool. My test passed. Now let's create a real failing test. We can create a test where the person is the correct age, but they enter an age too low to be updated as a new age limit. And then another test where we put like an age that doesn't work for what we're trying to do, which is like if someone is 16. So first, let's do one where someone fails the first AK proof correctly, fails when the person is younger than 18 than the age limit. So let's say the person is about 20, would that work? All right, so let's do one where the person is 16 and they want to update the age limit to 20. Wait, so therefore this should, so because we know this transaction is going to fail, let's just do a try and then catch. And then we know that the fail will still be 18 because we know that wasn't successful. All right, awesome. And let's do one more where the age that the person is valid. So they are 18 years old, but they tried to update the age limit to 16. So we know that this transaction will fail. And let's see if they printed the error. Yeah, so the error did print the last one. So yeah, we know I will fail and the age limit will actually still be 18. So it fails when person tries to update the age limit to a number that is too low. All right, well, our tests have passed. I haven't given you guys eye contact for a second, so yay. All right, awesome. Now that we've done that, we've literally written a very simple ZK proof. It's up to you as a developer to create the UI to accept the user input, for example, the actual birthday, which your code will then turn into the age and send to the ZK app. And mind you, all of these parameters here are actually private to the blockchain. So nodes in the blockchain don't actually see that number. And what that means is that they have now private inputs, so people don't actually know their birthday or their age, and they probably don't even know what number they chose to do the age limit, depending on if it's like a successful transaction. And they also don't know what age they put in for the new age limit. These two here are the constraints required for determining a valid ZK proof. So this script is essentially used if you want to deploy the smart contract and you would like to interact or send a transaction to a smart contract that's actually deployed on the public testnet. Let's do that in this video. So first, let me just make some changes in terms of add. It's no longer called add. It's called age verifier. Let me change this to age verifier. And then for now, let's just comment this. Actually, yeah, let's do it. So it'll be ZK app verify age, and then we'll pass in field 18. And new age is field 20. So just like a successful transaction for now. It's erroring because we probably have not imported this. So we can do import field from snarky.js. All right, so let's see if we can compile that. If we do npm run build, it's now going to build everything. And we want to be able to deploy this on the blockchain. So to deploy, there are some instructions on Mina. So how to deploy a ZK app. And first you need to go into the directory containing your smart contract and run zkconfig. And then you need to set it up based on this. You have to choose a name. So we're deploying to the Berkeley testnet, so give it the same name. And then the URL, which is the testnet URL. So one of these two. So I'll use the second one. And then also the fee. So the fee that you're paying for your gas fees, let's just say 0.1 for now. All right, so as a result of doing zkconfig, it has a file called config.json, which has information such as the place where you're deploying, the URL you're deploying to, and where you can find keys, which are the keys required for like the accounts they're using for deploying, such as the private key. So if you do ls key, you see berkeley.json. So if we do vi keys berkeley.json, we can see this is the public key and the private key. So with the public key, we are able to fund it, and there is a faucet, and thankfully they gave us a link here if we'd like to fund it to request test Mina. Of course, this is not real spendable Mina, just for the testnet. And just do request. It's already populated the Mina address, so that's wonderful. Invalid, none. Please try again. Cool. All right, awesome. So let's see. They said it'll take about 3 minutes when the next block is produced. So this probably hasn't been completed yet. And the next step, once that's done, is to deploy to Berkeley. Just remember that this is the name that you gave when you did Zig. So if you did a different name, then change this. Here it says pending transactions, so we'll just wait for that to be completed. By the way, don't forget to subscribe to this page, and Mina actually has this amazing incubator program where you can get your app ideas funded as well as get some help to figure out how to get things going. So it starts in June, sign up in the link below. So it's a really great opportunity. All right, so now we can see this transaction has completed. The next thing we're going to do is to deploy. So the step I think is ZK deploy, but let's double check. Yeah. So ZK deploy Berkeley. Let's see, build project. Okay, only one smart contracts exist. Age verifier. All right, generate verification key. So the generate verification key, at this step is where they're generating the verification key for the proof. Awesome. So send me a link where I can see how the transaction is doing. Oh, it's the next website. Okay, so this transaction is pending. So we are at this step here. We're deploying the smart contract. So we have a transaction. This transaction contains a verification key. That is this transaction that's running here. And it is being deployed to the Mina blockchain. So just to quickly explain that again, a ZK app consists of a UI and a smart contract. The smart contract is code that you write. In our case, the UI is our terminal. The smart contract consists of a prover function. The prover function is where we define the constraints for the ZK proof. So the prover function is a function which executes the smart contract's custom logic. So in our case, the custom logic that we have is here, right? And then when we want to deploy it to a blockchain, we generate a verification key, which is deployed in the smart contract. The verification key does live on chain for a given ZK app account and is used by the Mina network to verify that zero knowledge proof has met all the constraints defined in the prover function. A verification key is required in order to create a ZK app account. Yay! So now the smart contract is deployed. If we look at the smart contract that was just deployed, we can see that it has some state, and you can see it's 18, which is what we put as the age limit for the smart contract, and it has a verification key hash, which is created from the ZK app proof that we wrote in the compound statements. Basically, this hash was sent to the Mina blockchain, and this hash is used whenever we're verifying this ZK app. So now we can run our test code that interacts with the smart contract. So if we go back into interact.ts, we previously modified it so it can work. So let's do npm run build to make sure the file is compiled. And then we can do node in the build folder. You'd see that it's there. Let's build source. So now we can do node / interact. Oh, I have to also specify the network. So it's compiling the contract. It's building the transaction and creating the proof. Fee pay are not permitted to send. Let me check. Fee pay are not permitted to send. So I think we have to use another account to be able to send the transaction. So if I do zk config again and I call it Berkeley 2, just have a different name, and then I fund it again. So right now I'm just modifying interact.ts so that I can now import the second address that I've just created. So I'm just copying the code so that I can update it. I will not show the steps to this. I will just leave a link to my GitHub repo where you can find the updated interact.ts file. But once that's done, you should now have two addresses that's being referenced in this file, which is the app address, which is where the app was deployed, and then also the sender address, which is the address that's responsible for sending the transaction. Oh, so the transaction is being sent. The transaction is sent now, so my suspicions were right as to why it didn't work. All right, so that transaction has actually completed, so that's amazing. Let's take a look at the transaction. So what I'll do is I'll go to the smart contract address. In that address, we'll be able to see information about the blockchain state. So the state is now 20 and it was previously 18 when we first deployed the smart contract. So that means the update happened successfully. And here we see a list of transactions. So this transaction would have been the deployment, and then this transaction would have been the actual update transaction. Just for one quick check, I want to show you an example of a transaction not actually being sent to the Mina blockchain if it automatically fails the proof. So if we go back to interact.js and we change this transaction a bit and we say 16, because we know that age doesn't work, right? Then if I go here again and I try to run the transaction, let's see what happens. So it's compiling the contract, because remember the smart contract actually is interacted with on this terminal, and because we don't have the terminal running the contract right now, it's compiling it again from scratch. Okay, as expected, it has failed with an assayed failure, which means that there was something wrong with the data we put in, and we already know it's because the age limit is 20, sorry, and we put it as 16. Let's say we put the person's age as 21, so they do satisfy the age limit, but we try to update it to 16, which is another failing case. All right, that also failed. And just a reminder, so I'm just going to change this again. So I'm going to put a valid age. I'm going to change the age to, let's say 19. And just to show you that it works, I'm just going to click run. I'm not going to wait for that to be completed, but I just want to finish the video by saying thank you for watching. And if you have any ideas that you would like to use for ZK proofs, then definitely apply to the ZK app incubator program, where 500,000 USD tokens and 500,000 Mina tokens are available in prizes. So definitely check it out. It starts in June. Register with the link below, and let's talk more in the comments and subscribe. See you in the next one.